I suppose the topic of this conversation is actually pretty simple, but there's a few interesting elements that I want to touch through. So the topic is referred to as AI at the edge, and obviously we're talking about 5G and beyond. And I'll put down here a little bit of subnote, the art of the possible. And what I'd like to do is walk through with you over the next 50 odd minutes, just some of the, a bit shorter than that, so I'll leave time for Q&A. Some of the componentry, some of the design considerations, what people are doing, and of course, I'll make this deck available to you afterwards. It's really a bit of an exploration because different things work differently for different organizations. So I'd like to put a framework of consideration to you, and then depending on your unique circumstances, you can go from there.
Sir Michael, sorry to push you back. There's just a little bit disturbance with your audio. I don't know. Maybe it's something to do with your microphone. Is there a way for you to fix it?
Okay.
We can hear some crackling sound.
Is that a bit clearer for you now?
This is better.
Okay,
Thank you.
cool. Yes, the joys of Bluetooth. Thank you for pointing that out. And please stop me again if that doesn't behave. So obviously, we're talking about artificial intelligence. So the important consideration here, let's start with why. We're actually talking about data. So the two aspects here that are critical to understand with artificial intelligence is data being the world's most valuable resource now. And we're really talking about the ability to extract data from that. And that's what AI is. It extracts data from whatever source, extracts information from whatever source. And there's a variety of different data sources. Started with images, but it's gone to other things. And it's the chips and the AI and the software that give you actionable decisions and analytics. So really what we're talking about here is migrating your business, not to a digital business, because a digital business is purely a platform from which you can work. We're talking about going a step higher, where we're getting your business to an algorithmic stage. So this algorithmic business is by no means to replace people. In fact, quite the opposite. It's to enable people to do more things. So obviously we have challenges with scale, we have challenges with the speed, we have challenges with time zones and time and all these sort of things. And this is where, well, we can get machines to do things to allow others, humans, to do different things. So that's really a bit of the framework here around AI. Also, we get asked in Nvidia, okay, you make graphics cards. Why are you involved in this conversation? And we do, but we refer to them as GPUs. When we say GPUs, they're graphics processing units. Usually they do graphics, but they can do other things as well. In this case, we're talking about leveraging our GPUs for computational workloads, not graphical. And unfortunately, AI is an exceptionally complex mathematical place. So the massive scale out capabilities of our GPUs are what really enabled that. And that's what really started the launch of AI, really in about 2012. And people ask, how big are your GPUs? So I think the largest CPUs you can get at the moment have got about 64 cores. That may double in the next couple of years, which would be nice. Some of our bigger GPUs have got 10,700 cores. So they don't run operating systems, but they do a very good job of using computational capabilities massively parallel. And of course, you can put 8, 10 of those in a machine. In fact, referring back to the previous presenter from Supermicro, they have some amazing options for you, and you can really do some incredible things. So let's dive into a little bit more about how AI works, because this is really critical to understand for the edge. So AI has what I like to call 2 hemispheres of action. So if you're doing end-to-end AI, you're going to start on the left and work your way to the right. And we're going to focus on the right for most of this. So what we do is we take an untrained neural network model. And you may have heard of things such as PyTorch and TensorFlow and Caffe2 and things like that. They're frameworks, but fundamentally, a neural network model is in a computer sense, not dissimilar to the way that you have neurons in the brain. So for example, we've got the visual cortex at the back, we've got our emotional centers at the front, and they're, well, for want of a better term, pre-trained models. But we still have to add data to them over time. For those of you who are parents, let me give you an analogy here. You've got a young child and you would like to teach them to understand what a cat is. So what you do is you get books and books of pictures and pictures of cats, and you show these pictures to your child, and eventually they learn what a cat is. Now, it's actually quite hard to explain what a cat is. I mean, you might say 4 legs and furry, could be a dog, could be a cow, but so it's actually quite hard to explain. But now your child has a learning of a cat. And this is exactly how computers work. We take inordinately large quantities of data, in this case, pictures of cats, but it could be imaging data, it could be audio data, it could be written data, it could be sound. There's lots of different ways you can slice and dice the data. But this is where, when we push it back and forth through these models, it becomes exceptionally complex. And you can see on the picture there, at the end, you've got cat and dog. So this is what we call the output layer. Yes or no for cat. Training. So this is what we do in the data center, and we do it at scale. It's basically a high performance compute challenge. Then what we do is we take that trained model, kind of like taking an XML file, it's what we call weights and measures, and we put that onto an edge device. Now that edge device might be something as small as a mobile phone, or it could be a server. And in fact, I have one of Supermicro's very small servers at home that's roughly the size of a large hardback book. It has one of our cards in it, and one of our cards is in fact this small. It's called a T4. And that now does what we call inferencing, where you infer. So back to the child analogy, you spend a year training your child on pictures of cats, and then you point to an animal and say, cat or not cat? And if it's a really good looking cat, your child will say 100% cat. If the cat's a bit weird, let's say it's lost a leg or a tail, or it's in a color that your child hasn't seen before, maybe it's a tortoise shell or something like that, your child might go 80% cat, 90% cat, not certain, but probability yes. However, in computer land, the system no longer learns. That is purely inference. And that's what we do at the edge. Now, this edge inferencing piece gets really interesting, because now we've got data lifecycle flows. What happens with that unusual picture of a cat? You want to bring that back to your data center and retrain over time and push out an updated model over time. And that's the data and the training model lifecycle. Now, some people, what they do is they don't actually bother doing the training. They buy software off the shelf, custom off the shelf software, COTS, and they deploy that software. So they're only doing the part on the right-hand side here. They're only doing the inference. And that's fine. The pre-training is done by somebody else, and they will just deploy updated models over time. So how do we do this inferencing at scale? What do we do? How do we design this? And that's the bit I want to get into with the 5G and beyond aspects here. So let's focus on that inferencing piece. So if we look at this end-to-end model, first of all, because some people do both, we go from data center to edge and back. There may be cloud involved. In fact, there's a little reference here under the cloud to something called NGC. It's Nvidia catalog. It's basically an app store for AI in effect. As for the servers, well, there's a picture there of a standard 2RU server, which can probably hold anywhere up to 6 or maybe even 7 of our little T4 cards. There's also something called a Jetson there, and I'll show you a picture of that a bit later on too. That's what I'm going to call Ultra Edge. But these are the tools that can actually be used to do all the analysis work. And as I said, if you're developing your own, or if you have an off-the-shelf model that you've bought from somebody, your data might circle back in for more training. And many of these companies have cloud capabilities where they'll take unusual data that doesn't seem to be classified properly, and then take it back, do some more training, and refine the models to make them more accurate. The point here is there's a life cycle. So this life cycle is the same sort of life cycle that you have to cater for with any IT infrastructure. And whilst I'm talking about AI, we are talking about an IT infrastructure. So AI is to your business, or can be to your business when you deploy it, the same thing that is machinery is to a production company. It needs to work. It needs to work well. It can't be too bespoke and weird, because you need to scale. You need to have visibility. You need to have security. All these different things matter. So when we talk about edge, well, security is a concern. In fact, for some companies, it's the security of the AI model that they've trained. How do we secure that? And as well as the data that's on the box, and also the ability to ensure that that model isn't corrupted in some way, shape or form. So securing the infrastructure. Lots of different things to consider here. So I talked before about the end-to-end model. So this is where we have, if you are developing AI, you go through data preparation, then your training, then ideally we'd like to optimize the solution, and then we deploy it, manage it, and track it at scale. At the top there's a reference to pre-trained models. So this is our NGC, our catalog, our AI tool set that's in the cloud as a bit of an app store. Lots of things there to make you go faster. So this is what we're really talking about, second wave of AI. The first wave, everything was deployed in the data center. It was centralized, it was done at scale, it was done on big iron. Now we're talking about enabling AI at the edge. And as I said before, edge can come in a variety of different, well, form factors really, depending where you are, who you are, and what you're doing. So some of the examples we have here. So computer vision, that's a common one. That's a very, very common one. And computer vision can be used for anything from security, safety, town planning, can be used for inspection tools, all sorts of stuff. Immersive AR and VR, that's possible. That's more in the visual space. NLP is short for natural language processing. Now, natural language processing is not translation services. This is the same as with your Google device or your Alexa device or your Apple Siri device or HomePods, where you can talk to them. And they understand the context of your words. So that's a really critical piece there around what that looks like. And again, you can do it at the edge. You can take data into the edge. Those things usually do require some connectivity back to a cloud infrastructure of some sort. And I'll bring in the importance of latency a little bit later on there. So important considerations. And of course, we get to robotics. Robotics can be connected robotics, or they can be standalone robotics, so fully autonomous. And of course, we talk about digital twins. And digital twins, sometimes referred to as virtual twins, these are tools that can be live or they can be static. Usually, if they're live digital twins, for example, a live digital twin of a warehouse or a factory, this is where you want to take telemetry out of the real system, feed it into your virtual system, and take actions on it straight away. And of course, the challenge we've got here for these remote systems is the last mile access. So if you're going to feed all those intelligent capabilities into some form of edge device, obviously 5G, fiber to the node or whatever it may be, software-defined WANs, DOCSIS is for cable modems and the like. How thin is your piece of string that you're using to connect to? If it's, I mean, let's go back into the bad old days and talk about dial-up. Would that suffice here? Because when we're talking dial-up, we could be talking satellite type connections. So when we've got our AI capabilities at the edge, the question really is, what sort of connectivity do we have, do we need, and do we want to use both for feeding data back, but also for the management capabilities for those edge devices, which you can't ignore. So let's go a step further. Let's talk about how this is growing and what's happening. And by the way, I'll give some examples later on. I've probably got too many examples in the deck, so I'll trim that down. So we talk about lots and lots of connected things. So this is a bit of a 5G sort of thing, but obviously it talks about other connectivities as well. We're really talking about the rise of smart machines. And sometimes those smart machines are like your car. Now, many of those are connected, and over time they'll become more and more interconnected. I'm currently traveling, so I'm usually based in Melbourne. This week I'm in Sydney. And in Sydney, the local government authority for Sydney, Transport for New South Wales, is trying to create a connected cars system. So this is where your Teslas and other smart cars have the ability to talk to each other. And they have the ability to talk to the roads and talk back to central systems. So they don't just use Google Maps to figure out where there are problems, but we can actually manage traffic intelligently. So some people get routed via path A, some people get routed via path B, not because anyone's faster, but because if we use both, everybody's faster. Drones, the ability to use those to drop service capabilities for deliveries or whatever it may be. And you can actually see there's both a flying drone, but also a little storage box with wheels on it. So they're used for autonomous deliveries of food and things like that. And there's a variety of other mechanisms as well that can be used here. Smart traffic systems. Here in Australia, the majority of the traffic systems have an inductive magnetic loop. And when a car is parked over them or stopped over them, the system can detect traffic. If there's no inductive loop active, then there are no cars there. That's pretty basic because it doesn't tell you how deep the line of cars. Is it 1 car or is it 30 cars? Computer vision can do that. And then we have the question, do you want that for one intersection or do you want all the intersections to talk to each other? So innumerable cases here of connected environments. And 5G certainly will be a big picture of those, but it doesn't just have to be 5G. When we go a step further, we're talking about the Internet of Things. I actually don't like the Internet of Things term. I find it a bit limiting. So let me just change the term here. If you combine what's on the left with Internet of Things with what's on the right-hand side in artificial intelligence, Internet of Things sounds dumb. So let's change the term. Let's talk about an Internet of Recognition. What happens when those edge systems can actually see and understand what's going on? That there is a pedestrian in the middle of a road, we can't change the lights. That there is a car that's broken down in the middle of an intersection. That there's been an accident, that somebody's calling for help, or whatever it may be. And that may be something as simple as a smartwatch that somebody's wearing that says they've got heart problems, or somebody has fallen and they can't get up. Again, the use cases here are innumerable. And think about it, you can get a 5G smartwatch nowadays. Pretty simple to do, right? So we're talking about lots and lots of different capabilities where the edge devices have the capacity to recognize action, data, and perform analytical instructions based on the data that comes through and actually make decisions. Where is this going to happen? The answer is pretty much everywhere. So we talk about self-driving cars. Let's talk about self-flying planes. I've got a great agricultural example later on, but needless to say, in Australia, agribusiness is huge. It's a critical piece of what we do. But there's other aspects of this as well. So the top right-hand corner, we've got the smart cities. So town planners notoriously make decisions on very little information. So I'm pretty sure that your traffic is probably just as bad as my traffic here. Okay, how do we smarten it up? What do? We need data to make decisions. Now, sometimes that information we can gather over time, but do we have human beings who can stare at video for a time? Or can we extract intelligence from those videos over time? And you'd be amazed some of the smarts that we can get out of that, let alone, obviously healthcare is a really big one for diagnostic tracking, anything from retinal pathology and all sorts of amazing different goals there. There's a warehouse one there as well, a drone in a warehouse. This is one of my favorite ones. There's a startup in the US, and what they have is the capacity for a drone to fly up and down the aisles of a warehouse. So both height-wise, but also back and forth through the aisles. And what it does is, with multiple cameras, it scans what's on the shelf. So you actually have real-time analysis every, how often do you want the drone to go down? 5 minutes, 10 minutes. Now, when they started off, what they actually had was the drone was going back and forth, but only at night. It wasn't going down through the day because they had safety concerns with people. Well, that's changing. So you can do lots and lots of different things here. It can be very, very smart. So let's talk about the edge and what you need to take into account when you're designing an edge-based AI infrastructure, or even not AI, could be a little bit dumb. I'm going to get to what edge means in a minute, because there are different definitions of edge that our customers work through. And with that definition, they make different decisions. But there's a few things you need. The first thing is latency. Edge is defined to a large degree by how latent connections are. So if you have video taken at the edge for decision on, let's go back to the traffic, the road scenario again. That video stream has to go all the way through the network, so bandwidth considerations here, to a data center, information analyzed, and control information sent back to the endpoint to do something. So anything more than a couple of seconds latency is going to be a really big problem. For human interaction, latency can be as low, should be as low as about 7 milliseconds. Otherwise, you perceive a really big problem. The bandwidth problem is, you may have 5G, but do you really want to stream video back over that link back to your data center? Or if we take the traffic example, do you really want to stream video from one intersection may have half a dozen cameras, maybe more. So you think about the number of intersections you have there, not going to work. It's literally not going to work. You may still send back data, by the way. You may send back video. What you will mostly send back is, hey, there was a crash, so we've captured just these 15 seconds of the crash, and we're going to send that back for storage. Or we'll keep it for 3 days and have it available to you, but everything else gets wiped. And of course, data sovereignty. What does the security mean for you? Now, you may be thinking traffic cams, I don't really care. But what about those smart devices when people have got smartwatches and things like that? That's a problem. That's a really big problem. What happens when you have other medical devices? Again, problematic. So data security and data sovereignty are absolutely critical to make sure that you're not violating privacy concerns. In my home council of Melbourne, they have cameras in the streets, but the software that allows playback always has the faces blurred for privacy. They can be unblurred. There is capabilities for that, but by default, everything is blurred, and it requires police intervention for those to be unblurred. Right? So pretty remarkable stuff. But again, these are the sort of considerations that will lead you to, do I have a good edge? Or do I need to go more connected edge, less connected edge? What am I doing? So when we design the edge piece, obviously we've got a couple of different aspects. So first of all, you need to have some level of compute there. You also have to have generally some sort of networking, even if that networking is intermittent. And I'll come back to that one a bit later on, because if you've got an optimized autonomous stack at the edge, it doesn't necessarily have to be always connected. Your infrastructure needs to have a degree of security around it, and it needs to be robust. We should plan for failure. We should always plan for failure, but we should plan for resilience against that failure. So what sort of failures are we catering for? So I'll give you some examples of our hardware a little bit later on, and they come in a variety of form factors, but there are different ways to work on this. If you don't have these 3 capabilities, or these multiple capabilities here, your edge infrastructure is not going to work very well at all. So in an ideal space, what we get, regardless of the solution type you have, and the picture on the left is, not quite sure exactly what your solution may be, but this one obviously happens to be geospatial. Your service effectively feels like a cloud service. And by the way, that doesn't mean it has to be in the cloud. It means it feels like a cloud service. We deploy anywhere and it comes back to, well, headquarters in the data center, headquarters in a hosted cloud, headquarters in an actual cloud, whatever that may be. Your deployments should be as simple as possible. Absolutely as simple as possible. So the ability to deploy a new device or a replacement device or more devices should be pretty simple to do. And that's both click deployment and click on config. Hopefully you've got an open set of APIs. Often there's too much bespoke stuff in the marketplace, but regardless, open APIs are good. Security, so forgive me while I wax lyrical about this one for a second. I have a master's degree in cybersecurity, and this one really bugs me that enough people don't take this into account. We had some networks, some road networks in Victoria, my home state, for many, many years, where there were cabinets by the side of the road, and those cabinets had various devices in them. And when you opened up the lock, and the lock was no more complex than what you might have on a school locker, there were unsecured network ports, RJ45 ports. You could literally use a screwdriver to open one of those up, plug in a network device, and you'd have full unfettered access to the road network. That one really, really upsets me, right? So security is all about defense in depth. Now, there's a variety of ways to achieve that, but the same goes with any deployment here. You should plan for compromise, whether that be anything from ransomware to malicious attackers, to mistakes, to bugs and errors, and all sorts of things, right? So defense in depth is absolutely key there. But you also need to have visibility. So the monitoring and alerting piece is all about sight through to all the endpoints. We're talking the hardware, we're talking the software, we're talking the performance, we're talking historical. So you get that, as it says next, a beautiful unified dashboard that shows you all of the aspects of your environment. Most people focus on the AI analytics to show you what's happening there, but we're going to go a step further and say it's also about the deployment hardware, software, health states, all sorts of things. You want to know when part of your networks don't work. You want to know when part of your networks are unreachable. Again, we should plan for network outages. For those of you who aren't aware, Amazon had, AWS had a bit of an outage the last 24 hours. What if you deploy to cloud, what does that do for you? How well do your systems operate when they don't have connection, right? So you've got to cater for that. Excuse me, I think this went one too far there. Nope, that is okay. That slide does not want to stay there. That's really frustrating. I'll just talk about the previous slide. I don't know why that's not showing there, but it's what referred to as intelligent video analytics. So intelligent video analytics is basically CCTV with AI over the top. So CCTV requires a human being to sit and stare at a screen and go, this is happening, or that's happening. And the minute you look away and you look at the screen and something happens, when you look back, you don't see it. You can watch it on a recording afterwards, but you have to know something happened. So intelligent video analytics is I can literally sit here on my phone and do Facebook or whatever I'm doing on WhatsApp, and I don't need to look at the screen because the system will alert me when it detects one of the things that is bad. Somebody driving down a street the wrong way, somebody in an area they shouldn't be, a staff member in the wrong place, or a person of interest on campus, whatever it may be. This is an example of, so we refer to this as intelligent analytics, but this is an example of the type of solutions that people commonly deploy. To be fair, intelligent video analytics is probably the first stage of edge AI. So quite commonly, and I'll pick on that super micro server I have, it's literally about that wide, about that deep, has a single card in it, and that can handle 30 to 40 cameras. So that system quite simply, and it's very small and doesn't use much power, can very, very simply cater for multiple intersections, or you could have it monitoring the entire outside of a building for whatever it may be you're after. And it has the capability to run multiple different AI engines on it. So at certain doors, it might be doing listing for certain people out into the building. At other areas, it's watching for masks, people loitering, et cetera, et cetera, et cetera, right? It could be in a retail environment, looking for slips and trips and people falling, stock levels, 1,000 different reasons. The video is the start of this journey with AI, but there are many, many other things where we have a smart instrumented edge that are doing so much more. And now I'll focus on this slide. So this is a design question. People talk about edge. And look, forgive me here, I made a mistake of getting a degree in philosophy many, many years ago. So I learned that the questions you ask define the answers you get. So I'm going to ask the question, where is your edge? What does it look like? What does edge mean to you? So first of all, let me talk about Singapore, or maybe a big city. So let's talk about Manila, for example. So if you've got great connectivity in Manila, or as Singapore has incredible connectivity, the data center quite literally is the edge. Everything plumbs back in. It's fast, it's furious, everything's well connected, there's no problem. So I don't need to put a device way over there because the wiring back to the data center is really simple. Whether it be wired or wireless, the data center is the edge in the case of Singapore or maybe a big city like Manila. But then we've got areas that are not as well connected or not as well as fast connected. So I'm going to call this normal edge. So now let's pick on my home city of Melbourne. So it's a city of about 5 million people, so pretty substantial in size. And if you want to connect something from one end of the city to the other end of the city, so that's a good hour and a half, 2 hours driving back and forth, well, data center plumbing for latency, maybe not as good. So now we have an edge device that needs to be fully capable by itself. But it will still have a good, reliable, steady, pretty powerful, good bandwidth connection. But I don't want to send everything over the edge. So we're back to my cool little super micro server, or maybe a 2RU with more cards in it. Again, different form factors. Or maybe multiple of those servers if we have a really big site. But we will pretty much expect to be connected 24/7, 365, except for unusual outages. And it can operate independently by itself. So let's call that the normal edge. Then you've got super remote. Now, I understand the Philippines is an archipelago with a lot of different islands, and I'm sure some of those have intermittent connections. Australia. We're the world's biggest island, and we have very, very remote locations as well. So yeah, we're pretty big. So there's lots of places where connections go up, connections go down, or things are intermittent. We're having more and more natural disasters. So things like fires and floods can wipe out connections for 2 to 3 days at a time, quite simply. Or a storm can maybe have intermittent connectivity for something as small as a couple of hours. So now we need something that's pretty well robust and has the ability to operate independently for a long period of time. And of course, ultra edge is something that is very, very, very rarely connected, but it will occasionally have to remain connected to send back updated data, get updates, whatever it may be. The other thing I'm not talking about here is form factor, because form factor now, I have referred to my little cute small supermicro server or bigger server, 2RU industry standard server, or other things. In the data center, you might scale up where it's quite big to one of our DGXs or an 8-way box. That's okay too, that's a data center edge. But we're talking about lots of different options, and I'd like to come back to those in just a minute too, just to consider them. But let me start off with something that's really unique. So the board you're seeing on the right-hand side is roughly the size of 1.5 credit cards in terms of overall size, and it's about 2 credit cards thick. And that's our Jetson range. That's in fact the big one, Jetson AGX Xavier. It's our industrial one, so it's ruggedized. We've just announced a new one coming next year called Orin, which will be about 4 times as powerful. But this is quite literally a system on a chip, or a SoC. What this means is it's a fully bootable system. It's got an operating system, which is Linux. It's got ARM cores. It's got GPU cores. It is specifically designed to operate in, well, a ruggedized environment. Now, you don't buy it like this. You generally buy it in a small chassis. It looks like a small form factor PC. And usually they're ruggedized to cater for heat, weather, all sorts of things. And you can buy them with more network ports, 4G, whatever bits and pieces you need. It depends on what you're after there as to what that will look like. So lots of different options for you. Good for ruggedized edge pieces. The other thing about this is you can do a variety of different things, okay? Lots and lots and lots of different things. So I want you to have a bit of think about, and I'll leave this for you as a reference point, what AI can do. It can find out if something's there or not. It can find out what type of thing it is. It can see to what extent it's present. Think about flooding, pest infestation, deforestation, that sort of stuff. It can tell you what's going to happen next, prediction, so self-driving cars use that a lot, or again, weather. Recommendation engines, what should happen, and my favorite, which is natural language processing. Okay, so NLP. I'll also leave you with a whole bunch of use cases as well. But I just want to do a shout out to those people who are developing their own AI. We have these containers in our little app store on the web, NGC. So that's definitely worthwhile investigating if you're going to be developing your own stuff. As for the use cases, which will be in the slide example for you, COVID, obviously. Mask detection, body temperature, how many people are in a place for how long are they maintaining social distancing? We've got examples for retail, stop loss, helping customers, slips and trips, stock levels, all sorts of things. I don't really have to get too much into self-driving cars, but as I said before, the next future is connected self-driving cars, which brings us back to security. Smart cities. Oops, sorry, that's got some audio with it. Recycling, which is really quite powerful. In Australia, we have Domino's, who's using Edge AI for analysing their pizzas. And I kid you not, they are literally analysing pizzas, and it's very, very popular. And of course, safe cities, smart cities, and things along this nature, right? So as cities get bigger, analysing that stuff. And one of the last ones I want to leave you with, which is one of my favourites, is smart powered machinery. So I said before, Australia has a significant amount of agribusiness. So we have big problems with things like pesticide overuse and things like that. So smart machinery, which can, in fact, autonomous smart machinery, that can actually go over a plot of land, find where the invasive plant species are, zap them with a laser or spray them with a little bit of pesticide. Needless to say, the pesticide factories aren't happy about that. They want us to use more and spray everything, but we no longer have to do that. Also, invasive species of bugs, which can be analysed and then acted on accordingly. right? So some really, really powerful solutions. And you think about it, a system that might charge over solar all day and go and do that by itself and use a laser to kill plants, that's just awesome, right? Absolutely awesome use of drones or driven materials. You know, it's just incredible. So lots of different options, and edge is different for everybody. Right? So lots of different things here. And when you get the slide deck, you'll see there's quite a few other examples here as well that can be operated on the edge. Having said that, I'm going to finish my presentation there and pause for questions if there are any in either the Q&A window or the chat window. Feel free to post them.